Dear viewers, welcome to our channel. This is a question on abstract algebra group theory from CSIR NET December 2019. Here we are given that G is a group of order p to the power n where p is a prime number and n is strictly greater than 1. Then we will check that which of the following options are true. First of all, we write a theorem as if G is a finite group of order p to the power n where p is a prime number and n is greater or equals to 1, then the center of G, that is ZG, contains more than one element. That is greater than 1. The given question is a direct application of this theorem. So we can write, since order of G is equals to p to the power n where n is greater than 1 and p is a prime number, then order of ZG is strictly greater than 1. Thus, the center of G, that is ZG, has at least 2 elements and option 1 is correct. We will check for the other options. For option 2, we consider the dihedral group of order 8, which is 2 to the power 3. 2 is a prime number and 3 is a natural number strictly greater than 1. And dihedral group of order 8, which is denoted by D4 or sometimes D8, is the group of symmetries of a square. Let us check the elements of D4. Say A, B, C, D is a square. We rotate this by an angle of 90 degrees in the clockwise direction and get A, B, C, D. Again rotate this in the clockwise direction by an angle of 90 degrees and get A, B, C, D. Again rotate this and again if we rotate it, we will get the original square from where we started. A, B, C, D. So if we take R 90 degree or R as rotation of the square by 90 degree in the clockwise direction, then from the operations that we have just seen, we can say that R is an element of order 4. If we rotate the square 90 degree 4 times, then we get the original square with which we started, and let we denote the original square as the identity element. Again, consider the square A, B, C, D. We rotate or we apply the reflection with respect to this horizontal line that I have just drawn, then we will get if we apply this horizontal flip again, then we see that we will get back the original square with which we started. A, B, C, D. So if we denote F as the vertical flip, then we see that the order of F is 2. That is, on applying the vertical flip twice, we get back the original square. Now D4 is the group consisting of the elements, the original square, rotation by 90 degree, rotation by 180 degree, which is none other than R square, rotation by 270 degree, which is none other than R cube, and flip, vertical flip, RF, R square F, R cube F. This is the group D4, and D4 has certain properties. D4 is a non-abelian group. Since RF is not equals to FR, which can be easily checked. Thus, we are getting a group D4 of order 8. D4 is a group of order 8, 2 cube, which is non-abelian. Hence, option 2 is ruled out. For the third option, which says that G has exactly two normal subgroups, we consider the set or the group Z8. Z8 is the group of all integers modulo 8. Now Z8 is an abelian group. In fact, it is a cyclic group, and we know that of order 8. We know that zero is a subgroup of Z8. 0, 2, 4, 6 is a subgroup of Z8. Other than the zeroth subgroup and Z8, which means that also since Z8 is abelian, so this subgroup has to be a normal subgroup of Z8. Thus we are getting a normal subgroup of Z8 other than Z8 and 0 itself. Other than 0 and Z8 itself. So option 3 is also ruled out since Z8 is no longer a simple group. Option 3 is incorrect. For option 4, consider two groups Z8 and Z4 cross Z2. Both are groups of order 8. Z8 has order 8 and Z4 also has order 8. Now we know that if G is equals to H cross K is a finite group, and then G is cyclic if and only if GCD of order H and order K is equals to 1. Now we know that Z8 is a cyclic group of order 8. Z4 is a cyclic group of order 4. Z2 is a cyclic group of order 2, and GCD of 4 and 2 is equals to 2, which is not equals to 1. Thus Z4 cross Z2 is not cyclic. Hence Z8 is not isomorphic to Z4 cross Z2. Thus option 4 is also incorrect. Option 1 is the only correct option for this question. Thanks for watching. Please subscribe.